Assalamualaikum warahmatullahi wabarakatuh, and every good day to everybody. Welcome to static and dynamic course. So basically we have two separate course, but we can combine together in this subject, static and dynamics. So which is we don't learn the whole content of the static and also the whole content of the dynamics. So we are taking a little bit a certain chapter in the static and a certain chapter in dynamics. So basically now now in this first half of the semester we are going to study the static, and then the second half of the semester we are studying for dynamics. For the chapter now we are focused on the chapter 1. So basically chapter 1 is a general principle of the static. Okay, so they have some several topics in this chapter. So we need to understand what's the basic quantity and idealization of mechanics. Then we need to learn about the Newton's law of motion and gravitation, and also we need to apply our SI units, system of units. Then we have to know the standard procedure for performing numerical calculation, and last one we can check the general guide for the solving problem. So basically in this chapter we need to really understand what is mechanics, and also the fundamental concept, and also the unit measurement, and also the last one is the international system of unit, or the SI system. Okay, mechanics can be divided into three branches, which are rigid body mechanics, deformable body mechanics, and fluid mechanics. So we are talking fluid mechanics is we didn't focus on this static and dynamic. Fluid mechanics we have a separate course. So we have the rigid body and deformable body. So rigid body, the body is tight together, and then deformable body, the body can be deformed. So in this static and dynamics, we are focused on the rigid body mechanics. So deformable body mechanics you will learn in the subject material science, and fluid mechanics you will learn in the separate subjects, fluid mechanics. And now we are focused on rigid body. So here rigid body mechanics deal with the two areas, which the first area is static and the second area is dynamic. Okay, when we are focused on a static, so they have two main principle. We need to understand what the static. Static is generally we can say you can say that the equilibrium of body. So equilibrium of body meaning that is the object we can define as a not moving. So not move is at rest. But somehow when we are when dealing with the equation of the second law, force equal to ma, a is acceleration. When they have the constant velocity, when the constant velocity means acceleration becomes zero, so force equal to zero. So total force applied on that particular object or a body. So the object when the total resultant force equal to zero, so meaning that the object doesn't move. It's actually the static equilibrium of body. So we have the two principles. First one at rest, second one is a moving, but we must have the constant velocity. And the second one, the dynamics we are learned in the accelerated motion of body. Okay, they have four fundamental concepts in this static in our course. First one is length. Length is need to determine where is the position of the point in space. Mass is the quantity of the matter. Time is the event. Force, we have the push or pull, and by exerted by one body or on another body. So we need to analyze when we are talking about the static and dynamic. We need to analyze analyzation of that particular body that we want to study. First, now we can analyze it as a particle, as also a rigid body. The third one we can analyze as a concentrated force. If we analyze as particle, although the object is very big, but now we didn't study on that particular object only. We need just effect on the others on that particular object. For example, we have here you can see here it's called what they have some machine. So this one, when this object is tied up by the one cable, so this object we can analyze as a one particle. So now we want to focus on the strength of this cable to hold this object, for example. So we can analyze this object as a particle. So but this particle has a mass, and then the size can be neglected. So because now we didn't focus on this object. We only want to know the strength, the tension of this cable. The second one, this object can be analyzed as rigid body. So when we are talking about rigid body, they have a combination as a large number of particles. For example, the ship. So the ship, when we are talking about that, they will put some of the particle into the ship. The ship can be unbalanced. So now we want to study the balance of the ship. So the ship here is a rigid body. So when a rigid body, so they have an effect of moment, unbalance of moment. Okay. Whereby the particles, we didn't focus on the moment of particles, but rigid body we can mean as a moment. The last one is a concentrated force. So the effect of the loading. For example, here you can see here there is the concentrated force on this particle wheel. Okay, they have Newton's three law. We have the first law, second law, and third law. For example, first law is just recap what we have learned in physics last time. So the first law is meaning that when the object is at rest, when there are two concepts. When the object rests, it remain at rest. Or the objects remain moving at a constant velocity, will remain as a constant velocity. But if the object at rest, we apply the force on that particular object, the object will move. So if the object have the constant velocity, acceleration becomes zero. So we apply the force. So we actually apply brake or whatever. We pull out or push the object. The object will have the the velocity will not constant. So if generally if the particle is subjected to an unbalanced force, the concept will be out. For example, so the object will remain at rest. The object initially at rest will remain at rest. The object is initially at the constant velocity, will remain at constant velocity unless they have unless any external force applied on it. So second law, when the objects actually can be accelerated or decelerated by the external force. So meaning that this unbalanced force experience an acceleration they have that particular object. So meaning that the force is actually directly proportional to the acceleration. Okay. The third law is actually when we apply the force on that particular object, the object will return back the reaction. So when there is a force, when there is action, there will be a reaction. So same magnitude but different position, different direction. Sorry. So the last one, Newton's law of gravitational attraction. This one is actually the force gravitation between two particles, whereby they have a two mass m1 m2, mass each of two particles, and r is distance between two particles. Then we have this formula, the WGMME squared. So we need to utilize this formula. So the units of measurement. So for the units of measurement, we have the standard of international SI units. For example, force equal to ME is maintained only if the 3 units is called base unit and the forms is derived from the units. For example, M is a mass, and then E is acceleration, then F is equal to force. So SI unit specify the length in meter, time in second, and mass in kilogram. So force is a unit of the Newton, is derived from the ME. So in this equation, we have the mass multiplied by acceleration. Then acceleration has the unit of the distance, the length as a meters, and also the time a second. Mass is kilogram. So now, for example, this is a table. We have the international system units. The length is meter, time is second, mass in kilogram, force is Newton. Okay, thank you. We'll stop here and then we will continue the next topic. In this unit, we elaborate more on the units of measurement. Thank you. Bye bye.